Good afternoon, students. Joining for the second video, that is dissection of the heart. So, this is what the heart looks like, and you can see the pericardium surrounding the heart. And if you closely examine, you will also be able to see coronary arteries which are passing through the surface of the heart and then going deep into the myocardium, the muscular part of the heart. Coming to the basic structure of the heart, here what we can see is your atrium. So this small part, this much, which appears brownish, is one atrium. The other atrium on this side. So atrias are very small. So this is roughly a human size. Roughly, we have a close fist size. This is roughly that size. This is a goat's heart, almost equivalent to the human heart. So atrias, you can see they are very small, just above the ventricles, and the major part of the heart you will see those are the ventricles. So already I have cut and dissected so that it does not take time to dissect it later on. So we can directly focus to the heart customs. Now, what I've done is I've just made an incision over here just to go deep into the heart. And when I open this, you will be able to notice the left ventricle. It has the thickest muscular wall. And if you notice the right ventricle, it has considerably thick amount when compared to the atria, but not that thick when compared to the left ventricle. So left ventricle has the thickest muscular walls. We have a good reason because it has to pump blood to the farthest point of the body. Like the fingertips also it has to reach. The hair, the scalp, where the hair follicle is there, that area also it has to reach. So everywhere left ventricle is pumping through the aorta. So that requires more amount of pressure. Now, coming to the basic understanding, if you focus inside, you will be able to see the thin white fibers which are going and connecting to the valves out here. What you're looking at right now, this translucent structure, this is nothing but a bicuspid valve at the aperture between the left atrium and the left ventricle. So this is your bicuspid. If you notice, there are two cusps. So there will be two visible flaps which are seen over here and held by the thin filaments which I'm focusing right now. If you can see, very thin, minute, spider web-like appearance. This is your chordate tendinae connecting the flaps, that is your bicuspid valve, connecting to the papillary muscle. If you now see, I'll be focusing on the papillary muscle right now. If you focus here, you will be able to see a conical muscular projection which is on this side. See, so this is your conical muscular projection, that is papillary muscles. So these valves are being held by the papillary muscles, connected via chordate tendinae. So chordate tendinae will be very strong, and they are so strong that even if I try to lift the entire heart with this chordate tendinae, I can do that. See this. I'm just holding it with a chordate tendinae. The entire heart can be picked up by a chordate tendinae. And this was just one bundle. This was not all chordate tendinae together. So even one chordate tendinae is enough to hold the entire weight of the heart. So just imagine when multiple of them holding your valves in position. So no overturning is possible, and thereby preventing the backflow of blood. Okay. Now, when we see through these structures, what do I see? First thing, if you focus through this bicuspid structure, I'll be able to connect to the atrium. See this. So just demonstrating that how it connects to the atrium. So bicuspid, tricuspid, we already know they are between atrium and ventricle. See this. So when I pass this probe through the bicuspid valve, I'm able to connect to this atrium. Just to make it much more visible and piercing through this atrium. See this. Now it will be much more clear. So I was able to connect to the atrium. So what we write as a location present at the aperture between left atrium and left ventricle. So this was the bicuspid through the area where we can move. The second part, the ventricle is then, so here was one where I went right now through the probe I took through this. The second structure where I can go from is this part. So where I go from here, I'll be able to see the probe coming out. This is now coming out, not into the atria, into a vessel, that is left ventricle vessel, that is aorta. the largest artery of your body, and you can just see the diameter, and you will be able to understand it supplies blood this much amount. So when the ventricles contract, all blood rushes out through this structure that is nothing but your aorta. Now, when it receives blood, so left side when it receives, we already know now, the theory has been done already. So blood is received through the, if you can guess it, that is nothing but pulmonary vein. It is oxygenated blood. Okay. So when it is oxygenated, we already know it is pulmonary vein getting blood to the heart. And if you want to visualize that structure, that is this over here. So this is your pulmonary vein getting the blood into the ventricle. This you can see it is entering into the bicuspid. So it will be pumped through the atrium and it will enter into the ventricle. And when it leaves the ventricle, it will leave to this aorta. So pulmonary vein, aorta. Coming on to the right side. So when I compare the left side and the right side you will be able to notice the valves here are tricuspid, but one is stuck to the wall, so you can't see it. One is over here. This is a chordate tendon, which you can see a very thick filament over here, and you will be able to see a valve deep inside this thing. So I'll just dissect it further and try to focus it more. So I've just dissected it. Now you can see a better version. Now, when I focus here, you will be able to see two flaps again. This is not a bicuspid, this is a tricuspid. The third flap which is there is stuck to the ventricular walls, because when I dissected it, it has been stuck to this. So you will be able to see three flaps over here, which we call as tricuspid, which is on the right side. And if I see the thickness, you will be able to notice the right ventricle is slightly thinner when compared to the left ventricle. Now, again the same, when blood is received, it is received on the right side. If you remember, right side is received by the superior and inferior vena cava, which open. And when I point this probe, so if you can see, I can pass through this. So this is your right side, the superior and inferior vena cava. Okay. Then when the blood is received and the ventricles contract during ventricular systole, the blood leaves through this opening. So you will be able to see the probe. I'm just trying to get it to see this. So this was your aorta when we first saw. This is now the right side where it pumps blood, because this is all deoxygenated blood. This goes to the lungs for oxygenation. This is something called as pulmonary artery. And when I notice the difference between an artery and vein, you will see pulmonary artery as well as aorta both having thick muscular walls. And when I show you the veins, just a sec, I'll be able to focus on the veins. Now you can see this. So both getting blood to the heart, see this. Just notice the difference between the thickness. You will be able to find out when we make that diagram of artery and vein. Thick muscular walls are present for artery because this is blood under great pressure. Veins are getting blood under low pressure, so they don't need thick muscular walls. The opening may be large, but the walls, the sideward portion is not that great thickness because they have thin muscular walls. So remember this logic. And whenever you make the diagram, it should be visible that your muscles are shown, artery may thick, veins may the muscles need to be thin. That is nothing but utica media, what we call. So that should be visible and that will be helpful. So for understanding better, so this dissection was done for that purpose and I hope it is clear to us. And papillary muscles location, just remember, you have to mention thick, muscular, and you can add conical muscular projections of the ventricular walls or the muscles of the ventricle. So this is one papillary muscle. If you want to see one more, I can show you. We have two heart dissected here. Just a sec. See this. Maybe if I can dissect that papillary muscle, I'll be able to focus it better. Just a sec, I'll be able to dissect. So I've managed to dissect it further. And now what you're seeing is I've removed the papillary muscle which was stuck to the myocardium of the ventricle. And this, what you're looking at right now, this is nothing but the papillary muscle, which is literally now I've removed it. So it is just stuck to the chordate tendon and nowhere attached. Okay. This is the papillary muscle. So it holds on to the caudate tendon, thereby preventing the overturning of your atrioventricular veins. So just remember these locations because sometimes, yes, memorizing those locations can be confusing. So once you see the structure, it becomes more visible, like visual memory is better. So you'll be able to frame a sentence properly and remember the function also. So this is what you're looking at is nothing but the papillary muscle, which is myocardium calea, which was stuck here, and I've just managed to cut it and remove it. And this is the reason now it is here. So it was tightly stuck to the myocardium. Okay. And we know that the covering which is present on the heart, so this is your pericardium. So I just try to slice it. Mostly it is fat covering what you're looking at right now. So if I manage to remove thoda sa part, this is nothing but your pericardium ka part. So which can be removed and we can, without damaging the heart, the myocardium or anything, what we are removing right now is nothing but the pericardium. So this is all white because it has a lot of adipose tissue. If you remember 9 standard tissues topic, when we were discussing adipose is found around surrounding various vital organs of your body. See, so this is your pericardium. Pericardial fluid can't see because it is minute amount and in between two membranes, so we cannot find it out. So this is what we can see. This is your pericardium covering, protecting the heart from mechanical jerks and shocks. So just remember this, and I hope this will be useful for your location and function studies. Okay.